Alright guys, how is school? So a quick video on matrix. What is a matrix? A matrix is just a rectangular array of elements or numbers that are arranged in rows and columns. Okay, and what does it mean when you say order of matrix? So the order of matrix is just telling you how is this matrix or these numbers or elements, how are they arranged, right? So as I've said, we have what they call rows and columns. So the order of a matrix is given as m by n, where this m represents the rows and this n represents the column. In case you don't know what I'm talking about, if you have something like this, like I said, matrix is just a rectangular array of numbers. So if you have maybe any number inside of this matrix, 0, 1, 2, 3, 4, 5, 6, 7, 8, for instance. So this first line, or this line here, is called the first row. So let me call it row 1. This one is called the second row, and this one is called the third row. While these ones up and down is called the column. Let's call it column 1. This is column 2, and this is column 3. So all the elements in a matrix can be identified by what? By their order, or you can just specify it. For instance, if I say pick the element that is on row 2, column 3. So this is row 2 and this is column 3. So the row 2, column 3 element is what? 5, because it is on row 2 and it is on column 3 simultaneously. So the order of any matrix is just how many rows and how many columns does that matrix have. Okay, so in this case now, since it has 3 rows and 3 columns, this is a 3 by 3 matrix. What if you have a matrix like this? 1, 2, 3, 4, 5, 6. You can see that this one has how many rows? 2 rows and 3 columns. So you call it a 2 by 3 matrix. So this is a 2 by 3 matrix. So the order of any matrix is represented by m by n, and the m is the rows and the n is the column. Very simple. So let's be taking it one by one. So we now know what order is. So from here down to symmetric matrix, these are types of matrix. So I'm going to be doing it very fast. If you don't understand, pause the video and listen to what I said again. What is a row column? If you have a matrix, what is a row matrix? If you have a matrix that have only one row, for instance, 1, 2, 3, right? So you can see that we have only one row, even though we have 3 columns, right? So this is a what? 1 by 3 matrix. Well, let me put it this way: 1 by 3 matrix. So any matrix that have only one row is called a row matrix. Any matrix that have only one column is called a column matrix. For instance, if you have it like this, 1, 2, 3. So this is a column matrix, this is a row matrix. What is a square matrix? A square matrix is any matrix that the number of rows and the number of columns are the same. Example, if you have 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix, you get the idea. So if it's the matrix has an order that the rows and the columns are the same, it is called a square matrix. What is a null matrix? If you have a matrix, whether it is square or not, and all the elements in the matrix are 0, that is called a null or a 0 matrix. So that's the definition for this one. What is a diagonal matrix? Now you know what diagonal is in shapes, right? Let's say we have 1, 0, 0, 0, 2, 0, 0, 0, 4. Now I want you to notice in this matrix, the diagonal here, right, has what they call non-zero entities. So once the diagonal has a non-zero entity, it is called a diagonal matrix. Okay, now if the diagonal entries or the diagonal elements, if they are all the same, maybe 1, 1, 1 or 2, 2, 2, it is called a scalar matrix. It is called a scalar matrix. And in this case, because it is 1, 1, 1, it is also called an identity matrix. So a scalar matrix is a matrix that has the diagonal entry to be the same. So something like 4, 4, 4 is a scalar matrix. Okay, but if the scalar matrix has the entry 1 1 1, or let me put it simple. Let me make it simple for you. So if it is something like this, this is an identity matrix. So an identity matrix is a matrix that is a diagonal matrix whereby the diagonal entries are 1 1 1. Okay, so that is identity matrix. While scalar matrix, the diagonal is the same. Okay, so it can be 1 1 1, it can be 2 2 2, it can be anything. So diagonal matrix is that diagonal. It has a non-zero entity. So these three they are alike, but they are not the same. Now for this last one, symmetric matrix. Symmetric matrix is just where the matrix is equal to the transpose. So there's something called the transpose of a matrix. We're going to get into that maybe in another video. I'll do another video for that. For addition and subtraction of matrix. Now, you have to know two things about matrix, right? Before you can add or subtract two matrices, okay, let me do plus or minus, okay? Before you can add or subtract two matrices, number one, they have to have the same order. That means if this is a 2 by 2 matrix, this one also have to be a 2 by 2 matrix. If this is a 3 by 3 matrix, this one also have to be a 3 by 3 matrix, and so on and so forth. So you cannot have two matrices with different order, adding or subtracting themselves. That's the first point. Then the second point, this element is going to add and subtract the corresponding element on the other matrix that you are performing the operation with. For instance, if you want to get the addition of the both of them, let's call this matrix A and this matrix B. Okay, for instance, if I tell you to add A plus B, you will give me something like 1 plus 2, because they are corresponding element on the two matrix. You cannot add 1 plus 3 for me, because this one is row 1 column 1, this one is row 1 column 2. So this and this cannot add. It's row 1 column 1, we add row 1 column 1 on the other matrix. So 1 plus 2 will give you 3, 2 plus 3 will give you 5, 3 plus 4 will give you 7, and 4 plus 5 will give you 9. So addition and subtraction of matrix is very simple, just your normal addition, but they have to be the same order of matrix, and they have to add and subtract corresponding elements. Okay, now if you want to do A minus B, okay, so 1 minus 2, it will give you minus 1, 2 minus 3 will give you minus 1, 3 minus 4 will give you minus 1, and 4 minus 5 will give you minus 1. So coincidentally, so this is like minus 1 everywhere. I didn't plan that too, but anyway, so this is what you have. Alright, so scalar multiplication. What does scalar multiplication means? When you have a matrix, let's say A is 2, 3, minus 1, 4, just any matrix at all, and you want to multiply a matrix with a scalar. What do I mean by a scalar? Any number that's not a matrix, maybe 3 times A. Okay, so you want to multiply this matrix by what? 3. So it's very simple. What you just do is multiply 3 by everything. So it will give you 3 times 2 is 6, 3 times 3 is 9. This is minus 3 and 12. So this is it. So it's just simple. If you are multiplying a matrix by a scalar, just multiply every element in that matrix by that scalar. That's all. Alright, now looking at matrix multiplication. Not all matrices can multiply themselves. For two matrices to multiply themselves, they have to be defined. Now you know that the order of a matrix is what? Let's say m times n, and this m times n represents row and column. Let's say another matrix represents n times p. This is the row and the column. Why did I use this n 2 times? Now for two matrices to multiply themselves, the column of the first matrix, which is this n here, has to be the same as the row of the other matrix. I used to remember it by doing C. Ronaldo. You know, C. Ronaldo is a footballer. So I used to remember how to know matrix that can multiply. The column must be the same as the row of the next one. So if you have, for instance, if A is a 2 by 3 matrix and B is a 3 by 2 matrix. Yes, these two can multiply themselves because the column for A is the same as the row of B. So these two, AB, can multiply themselves. What if you have A to be 3 by 2 matrix and B is 3 by 2 matrix? Can A and B multiply? No, they cannot multiply. They cannot multiply because the column of A and the row of B are not the same. They have to be the same. Okay? So when you multiply this A and B now, you will not have a defined answer. But if you multiply this one, you have a defined answer, and your answer will give you a 2 by 2 matrix. If you do this multiplication now, you would have your result will be what? A 2 by 2 matrix, because this is 2 and this is 2. And it's only possible if this and this are the same. If the column from A and the row of B are the same, then your answer will give you a 2 by 2 matrix. So that is for you to know which and which matrix can multiply themselves. Of course, if they are square matrix, like if they have the same row and column, they can always multiply themselves, because a 2 by 2 matrix can multiply a 2 by 2 matrix. See, they are the same, and your answer will give you a 2 by 2 matrix. So any square matrix can multiply the same square matrix. Okay, so that's not even an issue. Where you're going to check all these things is if they are not square matrix. If they are not square matrix, if you don't have the same row and column, and you want to check if they are compatible, if they can multiply themselves, then you check this my Ronaldo rule, if the column and the row are the same. All right, so now what are the main rules of multiplying? So that Ronaldo rule I gave was just for you to know if two matrices can multiply themselves. So what are the main rules of multiplying? How do you multiply? For instance, let me give a simple matrix. If you have 2, 3, minus 1, 0, and you have another one, 3, 1, 4, 2, something like this. Okay, so you can see that this is a 2 by 2 matrix, and this is also a 2 by 2 matrix. If you don't understand what I mean by all these 2 by 2, 3 by 2, go back to where I was talking about order of matrix. Okay, so this row and column. Okay, now if they want to multiply, can they multiply? This and this are the same. Yes, they can multiply. So how do they multiply themselves? So AB will now be what? The row will multiply the column. Now when you are actually multiplying, it is the row that is multiplying the column. So each row will multiply the column. Now let me take it easy. Now this is the first row and this is the first column. So they are going to add the multiples of the row and the column. So let's start. So you do 2 times 3. 2 times 3 plus 3 times 4. 3 times 4. Okay, that's for the first element. For the second element, this row will multiply the second column. So 2 times 1, you do 2 times 1 plus 3 times 2. 3 times 2. Are you seeing? So that is how you do it. Then for you to go to the next row, you go to the next row here. Minus 1 times 3. Minus 1 times 3 will give you minus 1 times 3. Then you add it 0 times 4. 0 times 4. Are you seeing the way we are doing it? For us to come down, we came down here and multiply the first one. So for us to go here, we'll multiply this down with the second one, which is minus 1 times 1. Minus 1 times 1 plus 0 times 2. 0 times 2. So you just have to practice this thing for you to know the pattern. Okay, so this becomes 2 times 3 is 6 plus 3 times 4 is 12. 2 times 1 is 2 plus 3 times 2 is 6. Okay, so this is minus 3 plus 0. Hold on. Minus 1 plus 0. So this becomes 18, 8. minus 3 minus 1. Alright, so this is how to solve matrix by multiplication. Alright, let me do another example. Alright, so this is another question. This one is a little bit more complex. If you look at this question, you have, this is a what? This is a 2 row and 3 column. That is 2 by 3 matrix. And this is a 3 row and 2 column. This is a 3 by 2 matrix. Now this matrix A and this matrix B can multiply. It is defined because the column of the first matrix and the row of the second matrix are the same. So because they are the same, they can multiply each other. So let us look for AB. Now AB is very easy to get, right? So I said if you want to multiply, you do what? The row times the column. So this row will multiply this column, right? So 2 times 4 is 8, plus 3 times 5 is 15, plus 1 times 0 is 0. That is the first element. Of course, you know that when you multiply this and this, your answer will be what? A 2 by 2 matrix. So your answer should look like a 2 by 2 matrix. So for you to get the other part of your 2 by 2 matrix, you do this row times the next column. So this same row times the next column. So 2 times 1 is 2. 3 times 3 is 9. 1 times 1 is 1. Okay. So now we want to get the answers for down. These down entries of our new matrix. So you are going to go down and repeat the same process. So this down row times this first column will give us the down first element. So 0 times 4 is 0, plus minus 1 times 5 is minus 5, plus 2 times 0 is 0. So that is for this one. So for you to get this, you use that same what's it called, the lower row times the next column. So 0 times 1 is 0, minus 1 times 3 is minus 3, 2 times 1 is plus 2. So this is what your answer is going to look like. So AB becomes 0 plus 15, sorry, 8 plus 15, which is 23. 2 plus 9 plus 1 is 12. This is minus 5, and this is minus 1. So you can see two things you need to check when you want to multiply. The first thing you check is my multiplication, is it defined? How do you check? You check that C Ronaldo term I showed you, where is the column of the first one, which is 3 here, is it the same as the row of the second one? And if that is okay, then you now check when you want to multiply, you now multiply it by each row will multiply the column, you get this first part. This same row will multiply the next column, you get this part. The down row will multiply the first, you get this one. So just like that. Okay, so now I've talked about matrix multiplication. Now I think I'm going to stop here, but I'm going to do another video specifically for determinant and inverse, so that we can understand what it is very well. I don't want to rush it all in one video. So please, if you have any question on multiplication or any question on this one that I've spoken about in this video, you can drop your questions on the comment. I'm going to be in the comment, and that is the only place I'm going to be in to answer questions. Then I'll do another video on determinant and inverse. So please make sure that you watch that other video as well.